And now we're going to introduction of our next speaker. And he actually is like a person who I want to be at some moment. So basically he escaped academia successfully after Ph.D. and start working as a data scientist in Evolusys. And he actually have a nice CV because I checked it, and of course. And he did his master in robotics and AI and machine learning in Middle East Technical University in Ankara, and it's one of the leading polytechnic in Turkey. Also, not only really great for science and practical work they do, but also for the place where they are located. As I understand, it's a really beautiful place. Yeah, this is what I wrote on the webpage. And after this, he moved to Lausanne to work at EPFL at Human-Computer Interactions Group, where he was working on wearable devices, on detector and sensors, new algorithms for using sensors, and also for development of recommender system for healthy behavior change, which he's going to present today. But also because we have people who are active not only in academia or their work, but also as voluntaries. He was also president of a Turkey association, which is helping students from Turkey in Switzerland to be more social, to basically cope with being a foreigner in a country. And I know that it's a big help. So,
great. Thank you very much, Pavel, for the introduction. As he said, I was once here doing PhD, and some stuff don't change. I guess I'm one of the people between you and the apero, and I've been in Evolusys since October 2017, rather new in comparison to a 5-year of PhD. I'm also now a Microsoft certified professional. So I will ask for your interest to first, I'll talk a little bit about my company, and then we'll jump into the research topic, and then maybe just a couple of words about the different experience I have between academia and industry when it comes to data science. Evolusys is 30 colleagues strong company. And with our recent merger with the giant Beşle, we have now 9,000 collaborators. We are basically doing consultancy services. I belong to one of the two poles of the company, being the modern analytics. Here we deal with AI, big data, machine learning, Internet of Things, and end-to-end solutions. In our portfolio, we have worked with different companies so far. I can't name them because we have NDAs. But with a pharma company, we analyzed what was going wrong with their pill manufacturing machinery using machine learning. We had a classic recommender system for online shopping. Then we had a fintech client who asked us to develop them a recommender system for asset management. And speaking of asset management, we also went further to do some text analysis for sentiment analysis, subject analysis, in order to provide a better view for the end users. And also, when we mean data science, it's not only machine learning, but also orchestration and the storage of big data. And then the last example I would like to give is it was a data framework that targeted hundreds of thousands of end users from different countries. We dealt with the movement, storage, and the treatment of the data. Now, enough with the advertisements. Let's jump to the research. Let me talk about John, Mary, and Charlie. John is a very concerned young adult because he sees that obesity, diabetes, and heart-related diseases are the predators of our modern society. And the culprit behind these problems are unhealthy habits in our activities of daily living. So he's determined. He starts to wear a Fitbit to track his activities, and he starts his journey for behavior change. But you see, in theories of psychology, in many other fields, including smoking cessation, we already know that behavior change is quite difficult. So when you say, okay, World Health Organization recommends you to walk 10,000 steps, the story does not end for John, because if he is walking perhaps on a daily rate of 3,000 steps per day, he will say, well, this is a quite difficult thing to do, and you haven't shown me how to do it. And we propose you our service, Inspire. I'm joking, it's not service, it was my thesis topic. A recommender system that will help you to achieve that goal that you're desiring. When we talk about recommender systems, this animation describes the best of the classical understanding of recommender systems. We basically track people's behaviors, their ratings on certain products, and we will find similar users to him so that we can recommend the product that they like, or we are going to find similar items that he already liked before. Okay, but here's the problem with that. Let's say we have found for John people similar like him. Okay, walking the same steps as him. If we recommend these guys' activities, we are not going to help him improve his activeness. He's going to stay as a lazy cat. We can maybe try to inspire him with the high levels of activities. Maybe people who are already walking 10,000 steps. Okay, I bet they will continue walking around 10,000 steps per day. But if you recommend the patterns of these guys to John, he may have an injury or he might be demotivated. So instead, our system does something different. He finds people who were similar to John in the past, but nevertheless improved. So that by following these steps, John has a higher chance of having a healthy behavior change. Now, where's the magic behind this? Unbeknownst to John, as he was using our system, the system was already collecting data of other people and their behavioral responses to the recommendations in the past. Two examples were Mary and Charlie. They had similar activity patterns, but when introduced to a recommendation, they have responded differently to it. While Charlie relapsed back to his inactive lifestyle, and I'm ashamed to say that that's me, Mary managed to improve his level of activeness step by step. So that proved to be a good example for John to follow. So, of course, Mary and Charlie, they represent persona in our research. Charlie represents what we call as perhaps temporary responders or non-responders, and Mary represents the responders. So in this research, we proposed three contributions to the research community at that time. First, we showed how to curate the appropriate data, how to extract profiles of people, and then it was quite new by the time we started working on this research. How would we evaluate the overall quality of the recommendations themselves? So let's go step by step. So if there is anyone who worked with the recommender systems before, they're acquainted with the term cold start problem, which means that if I start using Netflix perhaps knows not much about me. It has to wait for me to rate some movies first or watch some movies first. It will try to elicit my preferences before properly recommending targeted content to me. So it will wait for me to basically rate some movies first. When it comes to our recommender system, we have the same problem. If someone starts using our system, we will know not so much about his level of activities unless he agrees to share his past data. So we will not only have to learn the patterns, but we should also know what would be the baby steps for this person to improve his level of activities. So we said, let's conduct user studies where we introduce interventions to our users and observe their responses, which could provide a baseline for our system to learn. So we have conducted a user study with Fitbit. We did not develop this sensor. It's an out-of-the-box solution, but we gave them to our participants. They warmed up for 2 days, and we then start recording their activities. And in the middle of the study, we have introduced our mobile application, which allowed them to pair up with other people as exercise buddies. And then with this social intervention taking place, we kept recording how their level of activities have changed. The resulting data set, we called it HD83. It's a time series data set of people's number of steps per day. 83 people participated in a varying lengths of days. And the good thing about this type of collection is that every person serves as a baseline of himself. We know the before and after of each user. When we have, after having collected this data, now it comes to the place where we analyze the time series data. This part of the research is really correlated with activity recognition research, where traditionally people collect sensor data along with some activity labels, do some clever feature engineering, and of course applying a good machine learning method so that we could detect what people are doing. The problem with this overall view is that the activity labels themselves are scarcely available. And even if people started to log what they are doing by themselves, there will be a lot of human bias involved. And when we look at the state-of-the-art studies at that time, we saw another limitation. The researchers said, okay, let's have a closed environment, full with sensor, and some experts are going to annotate what people have done. Well, they do produce some good results, but they are limited by the knowledge of the experts, and they can only track a certain subset of activities. So we instead proposed something different by exploiting a certain insight. We said, if people are following daily routines, it means that their days have minor differences but major similarities between each other. So our pipeline for our new method would put us some results like telling John he's a morning person, John perhaps is a person that is more active on the weekends. So because of the time limits, I won't be able to tell each and every step, but I want to talk the two core components here. And let's go back to metaphors to understand better. Let's imagine a wooden door. When you look at this door, and if you wanted to represent this as a composition of two things, you can choose the following way. You can represent it as a composition of the background door, which has some wooden texture, and the other component would be the iron knob, the other small decorations that are scattered across the table. When you translate this metaphor into matrix terminology, this would be a low-rank matrix. It means the rows are linearly correlated with each other. And that could represent the trends, the major similarities we have each day. And the doorknob, the little decorations which are scattered across across the door, it would be a sparse matrix, and that could represent the deviations of our activities. And for people who like formula, here's the formula of the one of the methods, the family of methods, which is known as low rank and sparse decomposition, or robust PCA. And the research on this topic is actually well covered. As a matter of fact, here is one snapshot from one of our labs in EPFL, from Lyon's lab. They used this a variation of this method to subtract the foreground and background objects. So as you can see, when we do this decomposition, we do have two useful information healthily separated from each other so that we can process them with higher accuracy. The next part was more about dealing the temporal aspect of the data. When you do clustering, which is what we did, you get to choose what sort of distance metric you would like to use. And we have noted that there exists a metric called dynamic time warping, which is quite better than the standard distance metric Euclidean as visualized here. So how would this help us? It will tell that, you know, if I woke up later than usual tomorrow and I had a shorter lunchtime, there will be, when you look at my time series data, there will be some nonlinear warps. But in a way, my Friday would be more or less similar to the rest of my days in the week. And don't be fooled when I say time series data. This distance metric is also used in signature recognition. You see that the signatures, they have some little warps, but nevertheless, we can match the signatures using this distance metric. Okay, so we applied this method and we obtained some clusters of people's activities of daily living. We were really excited just by looking at the pictures, saying, oh, maybe this is a commuter because he wakes up around 6, he doesn't move until the lunchtime, and then evening he returns, but then he sleeps. There is an afternoon person, morning people, people who take quite a lot of breaks. That's good for everyone. You know, we should walk every 30 minutes, get out of our desks. There are late night people who are more active in the night, and there's this exceptional group which I guess they really like cycling a lot or do hiking. Well, we conducted the study in Switzerland, so I guess that's natural to obtain. But maybe I'm getting too ahead of myself because that visual evaluation is incomplete. We did a quantitative evaluation as well. We used average silhouette width, which is a well accepted method to assess the quality of clustering. What we have observed is that our method produced very good quality of clusters, therefore capturing natural significant structures underlying in the data set. And I have omitted it, but I can share it in our papers, but we also managed to outperform the baseline methods for clustering. And that was one part of the profiling, because now we see the temporal nature of different people. But let's see how those people, those categories of people, respond to interventions, because that's also a key part. For this, what we used is something called interrupted time series analysis. It looks like a linear regression problem. And what we can demonstrate, I can demonstrate it as follows. Suppose that I started to move less over time, and then I have instead of going to the expected direction where I would decrease even more, I suddenly started to increase my level of activeness. We would like to, we can assess with this method to what extent our intervention, in other words, our recommendation, contributed towards that change. And we can deduce in this profiling the pre-recommendation slope, the post-recommendation slope, which are the daily rates of changes, and immediate change upon receiving an intervention. And with this way, we can mark the temporal profiles that I've shown you just before as responders, non-responders, or temporary responders. How does it work? Well, if the daily rate of change after the recommendation is significantly different and larger than 0, then we can say, wow, this guy has responded positively to our intervention. If there is an immediate increase which is not followed by a steady increase, these guys are temporary responders. And in other cases where the daily rate of change decreases or remains the same, we say, unfortunately, those people are non-responders. And when we did this analysis on our data, indeed, here we go. The temporary responders who spiked their level of activeness by 1,000 steps in the beginning, but then didn't have a daily rate of increase. Here are non-responders, and here are responders. But I want to take your attention to the numbers. The rate of increase is different for different categories of people, which suggests that we should not recommend the same thing, even if they have the propensity of becoming a responder. Finally, the recommendation itself. Here's the algorithm we have used. Basically, it says we identify the person's behavior profile, meaning its temporal characteristics and its intervention characteristics. And then we will recommend to him people who are not in his profile. Therefore, we evade the problem of similarity-based recommendation, but give examples from the closest people that are already responded well in previous recommendations. You can say, okay, Onur, you've been selling your idea, but does it really work? Well, to answer that, we have to ask 2 questions. For people like Charlie, we should see if the system is helping him improve. And for people like Mary, we should see that the system helps them maintain their rate of change, not crank it up to a high level or let the person slow down. Towards that end, we searched and found a nice distance metric, and we adopted to our case. It's called Disparity Score. Basically, we compared it compares 2 time series data, perhaps the user and his exercise partner over time, and to see how different they are overall. And for those people who know mean absolute error, this is a variant of it. And the larger disparity score means there's a larger difference between the 2 time series objects. Let's see it in action. In an earlier study which is called Healthy Together, where we introduced exercise partners, we had obtained some qualitative indications that partners are influencing the level of activeness of their exercise buddy. So we tried to quantify to what extent we can further validate this idea. Turns out that we obtained this picture. Allow me to explain. In fact, responders who really increased their activeness, they did so with their partner harmoniously, which is why their overall disparity scores are lower than those of non-responders and temporary responders. And it also hints that because the partners they were not really on the same wavelength in terms of activity frequency, non-responders and temporary responders could not improve their level of activeness. Using this insight, we compared also our recommender system with a similarity-based recommendation strategy. We see that the recommendations from similarity-based strategy and our method helps indeed non-responders and temporary responders to improve their level of activeness. On the other hand, it's only it's only our method, Inspire, that can help the responders maintain their current rate of change. It was a small victory for us, but we said, okay, maybe we were just too lucky with our data sets. Maybe in another domain, we will observe something different. So we searched for some other data sets, and luckily we found a study where people were logging their number of unhealthy snacks. And in the middle of the study, the researchers started to send them some persuasive messages, which were either tailored to their persuadability or not, or the messages were completely opposite to their persuadability profiles. So this data collection study is more or less the same to what we have already done for Healthy Together, our exercise data set. And there were 73 people who logged for 73 days. And when we applied our profiling, we again obtained non-responders. As you can see, their number of unhealthy snacks don't really change over time. There are some responders whose level of snacking reduce, but at different rates, and there's the temporary responders. They say, tomorrow I quit, they don't eat, but the next day they go binge over their snacks. And here are the lines that I introduced here that are recommendations. Of course, we cannot go back to 2012 with a time machine to give our recommendations, but this is what would it look like if they received the recommendations. And again, when we did this retrospective comparison with similarity-based recommender system and our recommender system, we found out that both of the recommender systems do help would help responders to maintain their rate of snack fasting, if you wish, but a similarity-based recommender system, just as I introduced in the beginning of our presentation, will not help non-responders and temporary responders. It's our strategy that actually is significantly different than what they have already done. We have two main conclusions I can draw. One is a rather practical. To our best knowledge, this system was the first to generate recommendations from wearable sensors to people so that they can increase their, to improve their activities of daily living. And theoretically, there is a study called the flow concept in psychology. It says that when the challenge at hand and the skills of the person matches, the person goes into a flow zone, therefore going directly into achieving his target. In a way, you can say that Inspire allows people to follow patterns which are not too easy, which would put them into boredom, or which are not like athlete grade, which would put them into anxiety or injury. A couple of recommendations for future researchers. By future researchers, I mean those who have already outperformed our methods. They should consider adopting intervention-based designs when they collect the data for recommender systems. They should consider the statistical properties of behavior patterns instead of trying to manually annotate the behavioral data. And when evaluating system, they should consider the trade-off between effective and feasible recommendations. The story is not over. Well, research is never over. I haven't told you how would I convince people to follow the recommendations I have given to you. In fact, it was really out of the scope of that research, but I would really like to hear this being done. That is adding persuadability profiles to people. And what about interpersonal recommendations? What about I ignore everybody else's data and I just look at my own past and get inspirations from my successful periods? And there are quite a lot of projects in Europe where they study detecting falls for elderly people. So our proactive system can be combined, integrated into such reactive systems to provide a complementary system for distant healthcare. And maybe recommendations with context. When I was doing Ph.D, I would walk to my office, so I was more active. But now I'm using public transportation. This change of context should be added to my recommendations so that I can keep being a healthy person. Okay, if we have just 3 minutes. Okay, 3 minutes. Sorry for too much time. I would like to tell you my personal experience on what changes when you go from academia to industry. Well, the priorities change. All words are valuable, but instead of research, we prioritize innovation. Instead of going deep into a certain technique, we try to go far. And instead of trying to do proof of concepts, we propose to our clients end-to-end solutions. Let me tell more. In this whole speech, I told you about machine learning, but when you are in the industry, you should be at least aware of the environment that is surrounding it. How do you ingest? How do you store the data? How do you serve to the end user? I'm not saying that you should be jack of all trades, then you would be master of none, but you should be aware of this thing. And also, going end to end also means that you shouldn't stop by just proposing implementations of your genius solutions. You should also follow with your clients, how do you link your business with artificial intelligence and big data? We came up with different profiles of clients, and we say if they want to identify, validate their business ideas with respect to machine learning, we can start with some tactical consulting. Then we start to show how they can collect data, and maybe we can train them how to become citizen data scientists themselves. If they are already having some ideas well connected, we do proof of concepts and implementations for them. And if they want to assert their leadership and they are already doing very well in AI and big data, we propose them some tailored benchmarking reports and additional implementations. That being said, I appreciate your patience, and I'll be more than happy to illuminate more any corners that you think I haven't enlightened yet. Thank you.
Questions. I just want to add that if you are very interested in more of what Onur did, we're going to add link to his thesis below the video.
No? Okay. That's great.
So,
I don't know how many people you've been engaging with for this pilot, let's say. What are the... Can you differentiate people now based on mood killers?
Based on mood killers. I'm afraid at some point this research had to stop, or I had to stop. But I can propose how you could deal with the mood killers. If you can manage to collect some additional data about what's happening in this person's life, or what is happening around, like maybe gathering news, you could do some sentiment analysis to detect emotions that commonly emerge, which could influence the level of activeness of this person. But also, if you're telling about mood killers as, maybe the person trying to follow up with a person that is too active, this should be already covered within the system, and the system shouldn't recommend things that would kill off the mood like that. Maybe not well answered.
In a lot of your project?
Well, it's in a retrospective, it's really fun.
The recommendation in context is really interesting because this is how I changed after moving from St. Gallen to Lausanne. I want to discover the city, so I jumped to average 10,000 steps per day for the past 1 month. And I want to ask, what's the approach, if you want to add this, to clustering the time series dataset with the change of location into a pipeline where you distinguish me from other people who are also have similar jobs but are different, like they are not moving. So how do you integrate these kind of features into your clustering pipeline such that you can really distinguish these kind of situations?
Okay, good questions. The answer is it depends. I can assume the worst and say that maybe you don't willfully disclose that information. You don't tell that you have changed your location, because if you tell that you have changed your location, all it takes is just partition the data and treat them separately while you do clustering. What you can do if there are no prior indicators is to try to see if there are some anomalous deviations from the existing activity patterns. If that is too significant to be considered as the past routine, you can introduce your cutoff from there. Therefore, that could be a nice way to enhance.
And also, you cannot collect data like with the standard, with the sensor like the GPS sensor, where you can really know the change of the location. You just have this nice application where you know people are varied. You don't know where it is.
Exactly, and also there's also another shortcoming. If you're inside the building, the GPS may not work. And that really would kill your chances of seeing the indoor activities. So GPS should be a complementary sensor, not the principal thing.
Maybe last question.
So I didn't really understand what you were recommending.
Okay.
It wasn't clear to me because you did the intervention, but this was not the recommendation. Right?
Yeah.
So exactly like you recommend exercise patterns.
The recommendations, concretely, they are exercise patterns, of course. But how it is introduced is perhaps out of the scope. But it should be presented with some means of persuasion, either through social means or showing, like maybe like many of those diet applications. If you follow these patterns over a month, you should be doing well. And if you're using Samsung Health, for instance, they are already on top of this game. They are already bombarding, at least me, with notifications. You shouldn't lag. You did well. Blah blah blah. And yeah.
Thank you very much.